Here's the video solution to problem 2a. I've got a rational equation here with three terms. First step to solving a rational equation is always to find that least common denominator. Here, in the two terms that are fractions, I've got a denominator that's the same, x minus 2. And then the third term, it's just a constant. So I can always rewrite that as a fraction with a denominator of 1, and in which case the denominator of 1 does not change the fact that the least common denominator here is x minus 2. Next thing I want to do, I'm going to rewrite the equation and multiply each term by that least common denominator. So here on the left side of the equation, I'm multiplying 5x over x minus 2 by the least common denominator of x minus 2. Same thing with the middle term of 7. And same thing with the third term, 10 over x minus 2. Multiply that by the least common denominator of x minus 2. The next step is to look for common factors that I can cancel out that appear in the numerator and the denominator. Here on the left side, I see I've got that x minus 2 factor in both, so I can cancel it. Nothing to do so far in the middle term there, and on the right side, I can do the same thing, cancel out that x minus 2 from the numerator and the denominator. What am I left with? 5x on the left side equals 7 times x minus 2. The only thing in the denominator when that's left is a 1, I can just cancel that out. I can ignore it. And then I've got a 10 that's left over from the third term. Let's go ahead and distribute this 7. And when I do that, I have 7x minus 14 plus 10. And now it's just a matter of solving this algebraic equation. I'm going to subtract 7x from both sides. When I do that, on the left side, I have a negative 2x. And on the right side, I can simplify the minus 14 plus 10 to a negative 4. I can divide both sides of this by negative 2, excuse me. And when I do that, I have x equals negative 4 divided by negative 2, which simplifies to x equals 2. Now, I always need to check for extraneous solutions when I'm talking about solving rational equations. What do I mean by that? Well, we need to check for every solution of x that we found, and remember, in some rational equations, there's more than one solution for x. We need to check them all by plugging them into the original equation to see if it results in any denominators equaling 0. So here, to check for extraneous solutions, I take my solution of 2, and I'm going to plug it in for x up in our original equation here. All right, when I take a 2 and plug it in for x in the first thing, 2 minus 2, this will result in a denominator of 0, which I cannot have. That results in an undefined fraction. So I know already that the solution of x equals 2 is extraneous. Since that is the only solution that I found for x, the answer to this question is that there is no solution. I could have plugged the x in for this in this term as well, and we would have gotten the same result. Again, the answer to question 2a is that there is no solution. The only value of x that we found that could have solved this turned out to be an extraneous solution. Therefore, there's no solution to this problem.